In this video, let's review the derivative of any exponential base. So if I have the function y equals b to the power of x, I know the derivative of that in respect to x is going to be y prime is equal to b to the power of x. Now again, it behaves very similar to that of the natural base, but then I have to tack on the natural log of b. So that's your derivative rule for that. Now, utilizing that, we're going to go ahead and prove that y equals the natural log base b of x has a derivative in a similar fashion. Okay? By doing this, we're going to go ahead and manipulate this function just like we manipulated the natural log of x function. Remember, we took this function right here and we changed it so that it was e to the power of y equals to x. We used the change of form on this. Again, we changed the form from exponential to logarithmic, or logarithmic to exponential. What's important about these two equations are the same. We're going to do the same thing with this one, where remember, log base b of anything equals to some kind of exponent. This is the base, this is the exponent, because every log is equal to an exponent, and now I have this. Notice again the similar dichotomy between these two forms. Okay? Now in this particular equation right here, if I'm going to take the derivative of it, or attempt to take the derivative of it, I'm going to simply apply d dx to both sides. And you'll notice this side right here is very simple. The derivative of x in respect to x is 1. And then we're going to go ahead and do this one. The derivative of a exponential function to the power of something is going to be that exponential function to the power of something, natural log of that base. Okay, again, notice the form right here. If I have b to the x, I get b to the x natural log of b. So if I have b to the y, I get b to the y natural log of b. But the detail that changes is that the derivative of the inside function must also be applied. The derivative of y is dy dx. So now I just have to get dy dx all by itself, and again, resubmit what y is, because I already know what y is. In that case, I'm going to have dy dx. If I divide both sides by this by natural log of b, I get 1 over by natural log of b. Again, by dividing both sides by this term. And then I'm going to replace my y with what it really is. Y is log base b of x and then natural log of b, which means, again, if we recall our identity formula functions of exponential and log, b to the power of log base b of anything is anything. So this is 1 over x natural log of b. This right here is the derivative of this function right here. Okay, so there's our rule, which is number 6. If y equals log base b of x, y prime equals to 1 over x. And again, notice the similarities between the logarithmic natural base derivative, this thing here, is 1 over x, to the base b of anything. It is 1 over x, whatever's inside, but don't forget to tack on that natural log of b also in the denominator. So that's number 6 there for your other logarithmic bases derivative rule.